All right, welcome everyone to the fifth and talk series. Um, and this session is going to be on the cloud with our speaker who is Mr. Faz from AWS. So if you haven't already, I'll give you a few seconds. You can always follow us on our Instagram. We have a lot of events coming your way, a lot of tech related. Even if you're not from the tech background, we have a lot of stuff for you. So our speaker here with us today is Mr. Faz, and he is a senior solutions architect at AWS Malaysia, who helps customers to architect and build products on the cloud. An architect and technical evangelist at heart, he speaks on various trends in the technology space with a focus on building and scaling in the cloud in and around Malaysia. He has designed and built products for over 16 years in the enterprise and SME space, along with building engineering teams and helping them scale. So, so what I'm going to do now is I'm going to let Faz take over. He's going to start his talk very soon. Right, Faz, the stage is yours. I'm going to stop sharing.
Awesome. Thanks, Nitin. Let me just quickly share my screen. Is it domination? Okay. Okay. Just put the chat box here so it's easier to see. Awesome. All right. Thank you so much, Nitin. And thanks everyone for joining in today. I know it's a Saturday afternoon, a pretty nice time to chill somewhere outside. But the fact that you're actually here to actually listen a bit about the cloud, it's great for that. It's great to see that there are folks who want to learn. And with that, I just wanted to say that I'm Faz. I'm a developer solutions architect, so a senior solutions architect in Malaysia for AWS. And I am someone who has been in this industry for over 16 years. I've been building products. I've been building engineering teams, and I've worked in a very number of languages. I mean, languages maybe even people who wouldn't have heard of before. And I've seen this industry grow over the years. I've seen how we have moved from what we would call as traditional infrastructure and then move towards this whole cloud paradigm, right? This whole idea of trying to move something into a server which you don't see anymore, a server which you can't see, but you know that things are working over the behind the scenes. And I'm going to talk a bit on some of that, and I'm going to talk a bit on even some of the basics so that I set a baseline with some of the folks. Some of you may already know a lot of this. This definitely is going to be part of a curriculum in terms of the basics of compute and stuff. But I've always seen that there will always be at least one or two folks who may not understand how all of this ties together back and then connected with the cloud. So I always try to start with that baseline. And that's something I've also seen over the years in my work in this industry also. So primarily in AWS, I help developers and I help customers build on the AWS cloud. And we'll be seeing in a bit on what the cloud is all about once I explain some of the basics. But just to give you an insight on what I actually do, so usually there are three perspectives. What customers think I do whenever I go and meet them. I mean, before the whole MCO thing happened, and now virtually is that I talk tech. So anytime someone gets me on a call, I'll be always talking about things. So customers think, okay, this guy's going to always talk about AWS stuff, and I'll draw with colorful markers on whiteboards. Always have a couple of markers with me to try to draw boxes and arrows and show, okay, your data's moving from here to here, and then bam, you're able to do certain things. What AWS thinks I do is that as a solutions architect, I'm actually talking and helping customers build products on AWS, explain to them what AWS can do, and influence them to choose AWS as a partner, as an IT infrastructure partner. But what I think I do, if you ask me personally, is that I'm helping foster this ecosystem of companies in Malaysia, whether they're startups, whether they're enterprise, or any kind of space you're talking about, and trying to help them to achieve what they couldn't achieve in the last number of years in terms of technology, right? Try to give them that acceleration through technology so that they can achieve the business goals they want. So that's what I'm thinking. That's what I believe my mission is, that I'm helping and looking out for always the next unicorns in Malaysia. So if any one of you are someone who's actually aiming for that, you know who to contact, right? To help you out on the AWS cloud. Also, I run a program out of Malaysia called the AWS DevX Mentor. Here's a QR code if you're interested to sign up and connect with us more and understand about what the program is. maybe you want certain feedback on projects you're working on, you can just connect back to us. However, at a high level, what this program does is that we help community speakers who are looking for assistance or looking for maybe guidance in content, samples of code or samples of other kind of content which they can speak on, and even guidance and mentoring. Because what I believe is that it's not about just a single individual or a single person who's supposed to go out and talk. It's about a lot of people, enabling more people to speak about technology so that they can understand and teach other people how to make more informed choices on technology. And this program helps us to empower individuals like this who are already switched on and they want to share more about the stuff they're working on. They're passionate about projects they're working on, whether it's open source, whether it's a project which you're working on in terms of trying to make money towards in the future, but you want to show people who may be potential customers later, right? Maybe 10 years even down the line or something like that. And what we do is we work with a buddy. You would work with a buddy SA. So a solutions architect like me would become a buddy for you, and we help you, guide you, and ensure that you're able to make impactful content and put it out there for people to listen to and learn from. So sign up to know more, and just reach out to us. In the feedback form, you can just put there's an extra field which talks about if you're interested in the mentor program or not. I'll be showing this towards the end again, so you have a chance at that time also to scan it. Cool. So quickly going on to the agenda, some of these things I may cover at a super high level because I usually keep this as a baseline. And for some of you, again, like I mentioned, if you see this is something that I'm already covering from a uni, just please hold on a bit and let's reach to the cloud part so that we complete some of this. So I'll get started with the basic fundamentals we're talking about, right? All of this talk about the cloud, all of this talk about infrastructure always comes down to this one key word which everyone talks about: servers, right? If you are someone who is building an application right now, or maybe you're in uni, you've been exposed to some of this already. You're learning in uni how to code. You're learning in uni about all the different concepts of computing and programming and data structures and stuff like that. And one of the things that always comes out at the end is that, okay, you've built something and it's usually on your local machine. Where does it go after next, right? How do you actually make other people use your whatever program you've built? And I had a very interesting interaction with a uni student in 2017, I believe. I usually share this anecdote because it gives you an idea of how still a lot of things that are being learned in terms of programming and all, they don't cover simple aspects of, okay, what do I do with the code I build? What do I do with the program I built after it's made, right? So I had this the student come over and tell me, okay, what is the cloud, right? And I told them, I asked them, okay, have you heard of, have you ever hosted a website before outside? No, I know how to code. That's what he told me. So I was like, okay, so you haven't hosted a website online, you haven't done this. All right, let me take it a few steps back. And then I started asking him, okay, you've written code. Perfect. Okay, so now where does it sit? It sits on your laptop, right? Okay, if you want to share it with your friend, what do? He thought of it and he said, I'll just share it on a USB stick. And I'm like, okay, fine. All right. So a USB stick works. So what if you want to do it for like 10 people, 20 people, 30 people? And he's like, right. Okay. I see your point. Then I told him, there is a server lab in your uni somewhere, right? Where you can actually go and put your application and then have other people come and host it. Come and access your application. And he was like, yeah, that makes sense. So now I just think the cloud is that kind of a server lab, but multiplied by 1,000 times, right? And you have all these massive data centers and managed services that are being offered out of this provider who would manage all of this for you. And all you have to do is you have to go onto the browser and then you have to log in, click on an account, and then just start building stuff, which we'll see in a demo towards the end. And that's when it clicked for him. And I think that's kind of like the key thing to understand in a lot of the cloud conversations we have with whoever it is, whether you're a uni student or whether you're already working somewhere, is that you need to go back to the fundamentals a bit just to understand why exactly do we need the cloud. And that's when you would actually be able to work better on the cloud. So I'll quickly just go through some of these basics. A server computer basically has three components, right? So it's no different from a normal computer which you would use, your laptops or your PC or gaming desktops which you're using. It is composed of CPU, memory, and disk. And the CPU is for compute processing, memory is for temporary storage for executing a program, and the disk is for storage of files, programs persistently, right? So you want to keep it for long-term storage and then access it when you want to. Maybe you've heard this explanation a couple of times, so I'm just going to explain how they work together to execute programs. Another perspective you want to see this from is also that the hardware that is used in a server is similar to hardware you would use in other devices which you're already using day to day, right? Apart from laptops, you also have a mobile device with you right now. This mobile device also has, RAM, it has memory, it has a CPU inside, it has also storage in terms of your memory card or SD card or micro SD card or whatever else you're using right now. And the difference over here between that kind of consumer grade hardware and whatever we would expect in a production grade hardware for a server is that the SLAs change. The service level acceptance you would want to have will change. Because if you're someone who's trying to host an application, you want to make sure that application is running 24/7, which means that the server, the hardware that it is hosted on has to run 24/7. So there should not be any failure. And even if there is failure, it should be able to handle it and get out of it as soon as possible. Also, you want, certain consumer devices have a certain set of features they can handle, right? Requests, for example, there are certain things that can go input and output in that cases. But you want a server to be able to handle something as simple as a data request where you maybe call an API, an application programmable interface, and request for some data back. And you would also want the same server to also do complex machine learning processing, right? You want to do some inference, you want to do maybe computer vision, detect objects in an image, and things like that. So you want to make sure that the hardware you're using is able to provide you all of this. The key thing to understand over here is the basics are still the same from a compute perspective, but when it comes to scale, that's when things start changing to a different degree altogether. So just stepping back a bit to keep it simple is that let's assume that you're doing some simple math, right? And we just want to understand how a human's calculation effort translates to something a computer can also do. So just take a simple example over here, 1 + 2, right? It's simple math, and your brain would do a certain process to get an answer in this case. So I'm just going to walk through the step by step. First, you get an input. And then after that, you got the number. So you get 1, and then you get 2. And then you memorize these 2 numbers, right? So you know, okay, you have 2 inputs, you have to store it somewhere. And once you store that, you would say, okay, let me do an operation. So in this case, I'll just do an addition, right? So the moment you add this, you get a result, which is 3. And immediately you say, aha, okay, I got a result. And then you would write this back on a whiteboard or on a paper or somewhere else, right? So it's a simple process when you see a simple equation like this. Now, similarly, that's where a CPU would come in, right? A computer has the central processing unit that does a similar step-by-step process, but it does it a bit differently in terms of the components it uses, right? So, I mean, being analogous a bit into how our brains function, in this case, you would have the CPU that would get an input. So it would get the operation and then it would get the numbers. For folks who are from a data structure and even a compute course would understand about compilers a bit. They would understand how inputs are taken in and then they're processed in a certain manner based on the sequence and also based on certain parameters that are added as part of the sequence. So you get something as simple as, okay, an operation add, and I want to add 2 numbers. And then the CPU has to remember these 2 numbers somewhere. That's where it would store it in a register, a very temporary storage, where it would keep this numbers closer to the actual unit that is going to process it, which in our case is the algorithmic logical unit. Sometimes it's a tongue twister. And this would calculate something, right? And the moment it calculates it, it's going to put it back into a register, temporary storage again, so that it can send it back to whoever has invoked the operation. And the thing is, the CPU has to remember to write this down, right, in a register as much as possible. And that's basically how the flow would work. Now, this works, you would want to then see, okay, once a CPU, you understand CPUs function in a certain manner like this, you want to be able to say, okay, how do you know what is a good CPU, right? And usually a metric you would use for that is, okay, a performance metric called clock, right, Hertz. It's a speed of a processor, because by default, a CPU reads line by line and performs the operation, right? As much as possible, it will just go by the sequence of operations that have been given to it so that it can handle those operations better. And when you usually say a CPU clock is high, it means a CPU can process a lot of lines at the same time. So you're getting that part of parallel processing slowly coming in at a CPU level. So usually what you would do is to make better performance out of a CPU, you would want to have a high clock rate, right? But it if a clock rate goes high, and for folks who are in gaming desktops and GPUs, they would kind of know this. If the clock rate goes high, then you also generate a lot of heat. So to handle this heat, you need to add a cooler behind, and there is a limit also beyond which you can't handle it. So that's why there's usually an upper limit of 4 gigahertz. A 4 gigahertz upper limit in terms of core performance. Now, if you know there's a limit, what do you do next, right? So you'd say, okay, fine, let me add more cores. So you start adding more cores inside a single CPU. So it's kind of like saying, okay, you have multiple brains inside a certain CPU. And that's where the term dual core, triple core, quad core start coming in. So I come from a time where Pentium processors, and even before that, at least when I started using before Pentium, used to be just single cores. The first time a dual core came, it was a massive thing for us, right? It was around the same time when we also had I believe 256 MB RAM. I guess it was around the same time, I guess. So 256 MB RAM and dual core processors were a big thing in my time. And yeah, how times have changed. So you actually now start having multiple cores as a normal option. Even your phones also have multiple cores inside, right? I think we are already at 8 or 16 cores already in gaming phones, I believe. And this makes it stronger and faster from a core perspective, but you also still want to achieve more performance. And one of the ways you can achieve that is by lowering the latency. So in this case, you want to lower the latency which occurs when a CPU processes data. You want to keep the memory closer to the CPU and inside the CPU. So you keep a cache. This is where the L5 cache starts coming in. If anyone's read any of the CPU specs, processor specs, usually you'll see this mention of a cache also inside. And the idea is to keep a lot of data as much as possible closer to the CPU so that it can process things faster, right? So you place input data near to the CPU, and for folks who are maybe already hosting websites, this is analogous to using a CDN, right? A content delivery network on a current cloud infrastructure kind of a thing, right? So you would use a CDN to store assets, you would store images, you would store websites and media files, for example, so that whoever is closer to that location, they get it faster. So think of caching like that. And it's ironical that I have to explain caching using current technology when it's actually been there for many years. But yeah. Now with CPU performance optimization at a high level, this is what you're looking at. So you have core performance, you have multi-core, you have CPU caching, and then you also have started getting more workload optimized units, right? Before, CPUs used to be very general compute. Now you have CPUs that are specific for graphics processing, and now even for machine learning for that matter. And in machine learning also, there are different types of processing units that are coming out. Tensor processing units, for example, for handling more tensors, right? In that case, GPUs in general can now do both graphics and machine learning also. So a lot of things happening on the chip side, and that kind of gives you an idea of where we are at in terms of a chip or a processor perspective. And that's one component of what you would get on the cloud also, right? So next up after that is the memory itself. And memory is something that comes out of the CPU. It basically stores program and execution, and it stores it over a time period of the lifetime, or maybe the time until which the machine or the server is powered up. The moment you power it down, it loses that memory, right? And the whole reason of keeping this memory, basically, which is RAM in this case, is that you want to keep code and data closer to the CPU again, but you want to keep more data so that you can process things faster. So the CPU fetches the code and data from memory to execute the program. And you would actually keep a memory in between a disk, which is basically permanent storage, and actual CPU in this case. So to just give you a very simple idea, this is how it looks like in your current day-to-day usage, right? On your laptops, on your PCs, or even on your phone. So you have a desktop and you have certain applications that are stored on a disk. The moment you go to your desktop and you click on a shortcut, it will then load the binary of the program into your memory, right? Which is your RAM basically. So all the related files and all the related code that is needed to execute that program load in, and the CPU starts processing. Which is why you'll always notice CPU. Anytime you see there's a slowness in your machine, you will actually go to whichever operating system you're using, check the performance, and you'll see CPU and memory is always there, right? And usually you free up the memory first so that you have more memory to run other programs, and you will try to remove the CPU intensive ones so that other programs get a chance to execute on the CPU. So you are still constrained. You're still constrained by a physical limit over here, because in your desktop, for example, you may have certain amount of cores, but you may still open up more programs, right? And then hit that limit. And today's example of hitting the limit faster is, I don't know how many of you do this, but I'm basically guilty of it, is opening up hundreds of tabs in Chrome. right? Or in any browser you're used to. And I have to actually use extra extensions just to manage all those tabs also at the same time. So yeah, that's like, we call them first world problems. Yeah, that's where we're at in terms of evolution of compute. And with memory also, it's something that's evolved over the years. So I come from a time where this was the norm for storages, right? So I come from the floppy disk era. When I was a kid, these big floppy disks is what I started with. And then when I was in uni, my final year project was in this 1.44 MB floppy disk over here. And this is also something I used to have trouble with because it used to get corrupted easily. You'll usually put it near a cooler, you'll put it near anything that's giving out a magnetic field, and bam, it's over. Your data's gone. My project files have gone. So that's how I started. But over the years, things have become easier, at least in my eyes. We started moving towards flash disks. We started moving towards a USB storage, and it's still a norm, right? Almost everyone I know has a pen drive. And now they use micro SD cards as pen drives also. And they all use flash memory, which basically is much faster than having disks in general. And then this is still at a personal level. But when you start going at a server grade level, you're looking at data centers, you're actually looking at farms, right? Arrays and arrays of disk arrays. So massive storages where you're having a lot of hot swappable disks you can keep plopping in and removing out, and replacing it, and all replicating across each other using the RAID configurations, for example. And that's how basically your data center storage would look like. You go inside this picture would look like maybe a tower of multiple disks that are like double my height, and then spanning across meters and meters of area within a data center, all cooled across, because a lot of disks are running, right? And on the disk, just sticking to that whole medium aspect, you also have two types of disks usually you would see in front of you. The first one is a hard disk drive, right? So this is a circular disk storage. It is a rotational type of storage where you will have a spindle of some sort that will the head basically is searching for a certain sector, and then afterwards it will search for the data and then put it up. So whenever we used to call in the old days disk corruption, or maybe a block sector corruption, it used to always be in one certain aspect over here somewhere where disk data would be corrupted, but everything else would work. So you would want to fix one sector and do it. Now that's changed, right? Now we have SSDs as a norm, and even though it's still a bit expensive, it's still something that is now used for day-to-day use, and uses electrical signals to read and write data, so you don't have any moving parts. But because of that, it's also a bit more expensive than hard disks. At a high level, this is how a hard disk would work. So you know where you will have something known as a file allocation table. That's where FAT32, the file system on Windows, gets its name, and you would have an index table, like a dictionary or sorts of, which this file if this file, let's say a Word document, is broken up into multiple blocks, what is the address and where is it stored inside? So the head would start spinning and go to the specific sectors and get those blocks back, and then show those blocks directly, right? So that's basically how it works in that case. So when you connect all these things together, that's when you start looking at this whole picture of getting a server, right? So you get a server, you get hardware resources in the server, and you are having memory, and then you're having disk, and now it's done. But that's just the beginning, right? Now, in the old days, when we used to write applications before, and we used to give it out to companies, right? When I started in this industry also, we needed a way to share all this data, right, across to other people, have other people also connect onto these applications and then use it. That's where this whole idea of a network started coming in, right? So this whole idea of interconnectivity between different servers, between different machines, so that you can pass data across, maybe within the same floor or across buildings. And now, thanks to the internet, now we are basically talking about global reach. So you're talking across the world also in that case. So very high level, I'll just quickly just go through this just for the sake of level setting, is that you would have different devices that are trying to connect and send files to each other, right? So in today's world, we have a computer that wants to send a file to a printer, for example, to print, and then you have a presentation or a video file that has to be downloaded to a mobile device from a certain remote location. Then you have emails that are being sent out since the 90s from a consumer perspective, and even much before that from the researchers before in Bell Labs and other places. So they would want to send emails from one PC to another PC. So all of this has to get routed in some form or the other. So you would have some kind of a router or a gateway in the middle that would allow you to send things across, right? So in the old days, we used to have physical links. I still remember my first network I set up was a gaming network in my uni. It was basically a pirate gaming network, because the idea was that we were not supposed to have gaming networks at that time. So we would do that. But yeah, now things have changed. Everything has changed so much. And I remember how I would configure all the networks across, put static IP addresses and make sure everything connects. And now how things have changed again, right? So now you have Wi-Fi routers, which have just become the norm, right? I'm connected right now over a Wi-Fi router, talking to you wirelessly, literally. And we're still all connected in this form or the other. Plus, you have devices that can communicate with each other also over wirelessly, right? So you can communicate between your phone using Bluetooth and other wireless modes. Now, one of the things to understand over here is that networks, just because you plug two things together, doesn't mean that they're going to talk automatically, right? Because they all would have their own way of doing things. So in this case, when you have two machines that are talking different languages, how do you ensure that they are actually able to talk together? That's basically where you would want to start looking at a common language, or in this case, we call it a protocol. And this protocol would have a certain definition of how exactly you're supposed to send data across, in what form, right? So you have different. You would break the data down into different packets, and then after know that each packet has a certain reason for existence, and send that across. And if anyone's interested in networking, you can definitely reach out to me. There's an awesome video we have from one of our Amazonians who shared it on our conference at reInvent about in 2015 and 2016. I believe he's done the talks. It's like a day in the life of a billion packets. And it's an awesome talk about, if you really want to understand networking at scale, and also, of course, from an AWS perspective. So definitely reach out to me if you're interested in learning more about that. At a high level, you would see that, right, so a set of rules over here. So at a high level, you would see that there are different types of networks, right? A very basic one would be just taking a Cat5 cable and then this Ethernet cable, just connecting it to the other side. But then when you start looking at servers, this is how it's going to look like. So you would have all these wires being pulled out from different server racks, which are able to push data and pull data down from different server devices. This is how it would look like from another perspective. And you would have cables moving up on the ceiling. So that way it's easier to access them later if needed. That's basically how you do. And usually if it's in the same physical location, you would have a local area network, because data is always faster on the wire versus wirelessly. So whichever way you see it, you still get more speed because there's less data, less speed loss, you could say, less latency in terms of just sending it over wires versus this. And this is basically what you call a local area network, or a LAN. And then when you are in an area where you want to connect multiple networks together, you would want to have a router which would then, and a gateway which would then connect you back to the internet, worldwide internet, right? And then your whole office, for example, in this case, so you have 2 networks, 3 networks in this case, which would want to connect together between themselves, and also to things outside the physical location. That's where you would bring a router or a gateway of some sort. Now, what if you want to go like to a much larger network, right? And that's where things start becoming interesting. And this is where you would want to start leveraging off of global networks that are available. Things like this that are networks like this that are using submarine cables, for example, and having their own interconnectivity. This picture, by the way, is basically the AWS global network. It's the Amazon global network, and it's 100% Amazon controlled resources. So if you're transferring data from, let's say, one region, which I'll talk a bit later what a region is, if it's from one region to another, so let's say from here in Singapore all the way to India, or from Singapore all the way to Sydney, it would then be flowing on that network, and it's completely managed by Amazon. Every one of those links are 100 gig networks. 100 gig absolutely everywhere. In many cases, it's simply not enough. So in a lot of cases, we also have many parallel links, right? So to ensure that we have redundancy in data, redundancy in the network, and we want to operate as much as possible without impact through link cuts. Link cuts is something which you'll always keep hearing. You must have heard it in the news every couple of months. A submarine cable gets cut for some reason, and suddenly, network speeds drop. And usually the complaints come in when people are not able to watch cat videos on YouTube. But yeah, that's how it is. So at a high level, that's what you would see in networks. Now, if you tie all this together, so you have networks and then you have all the storage, and I haven't spoken about all the other kind of applications you would look at, right? So if you're a developer, you're building applications, you would be also looking at hosting your application in a server and then hosting something known as a database. A database primarily is like a monolith application that hosts all your data for your application. Traditionally, it has been a relational database, right? So you would have a strict schema and strict relations between the data. You would normalize the data and then store it. And then this massive database would manage all that relationship and the compute on top of that. And then you would fire SQL queries on top of that. But even that has also changed over the years. The fact that databases can be now more spread out, right? And you have also NoSQL databases that are more optimized for high scale reads, for example, in this case, and other things. So take all of this together, and then we start looking at this whole concept of infrastructure. And infrastructure is something, as a word, it's always used heavily. In a nutshell, what you would call it is it's composed of a lot of hardware, right? Infrastructure is basically a lot of hardware. And this infrastructure would contain a bunch of servers, and these servers are managed. These servers are managed in a server rack, for example. If anyone has seen a server rack anywhere where you have all these blades which you would put in, and this server rack is basically like a hardware cabinet, and then you have a bunch of cabinets, right? And you have lots of these across in a building or multiple buildings, and that becomes your data center. And that data center is basically, multiple data centers, you would call it as infrastructure at a high level in normal parlance. Now, when it comes to cloud, that's where things change a bit. With AWS, this is how it looks like. With AWS, you're looking at various types of servers which have different types of optimization, right? So you would have components that are compute optimized, where you can host more virtual machines and containers. You would have something that's memory optimized, so that it can execute things faster in memory, right? For maybe having caches, like maybe if you're someone who's using Redis, for example. Then storage optimized components, which is allowing you to store massive amounts of data. If you're basically into maybe data analytics, or maybe you're into machine learning, so you want to access data faster and then process that and then put it back again in. And you have all these various types of servers, and then again similar, you would have different racks which are managed by AWS, and then all of these racks are put into data centers, and then you have something known as an availability zone in AWS, which is basically a collection of data centers which then are collected. And when you have these multiple availability zones which are set across a geographical location for redundancy, for disaster recovery perspective and all, you get something known as an AWS region, which is a geographical location having multiple availability zones, which allow you as a developer or someone who's managing applications to write code and then architect it in such a way so that you can take advantage of having redundancy across, so that even if, let's say, one node fails in one place, you still have your application running and your users still able to manage those applications and use those applications better. So at a high level, a data center is basically a server building. It's a facility. You have building facilities, you have air conditioners, fire extinguishers. So that's the physical aspect of the location. Then you have servers and storages, and then you have a lot of network, right? Interconnectivity between those machines, then interconnectivity from the data center all the way to other data centers, and then globally to a network, so that you can do it. Now, if you notice, this is a lot to take in, right? This is a lot of things you have to handle. And this is basically heavy lifting that you would have to manage. If, let's say, you're maybe as a developer, it's abstracted from you because you have another team that is going to do that for you. But still, you need to, as a company would need to manage a team who's able to manage data centers, manage all these labs, and do all of these things. And that's where this whole premise of having the cloud comes in, right? And with the cloud, what you're looking at is that you have all this compute and network and storage all optimized for you, for your application usage, provided to you over the internet, just at a click of a button, right? So you go to the browser, you are able to spin up things, and you're just able to do it without having the issue to manage all of this. So all this undifferentiated heavy lifting is all taken care for you, right? And you can just worry about your application. You can just worry about your basic business applications which you're building in that case. So with this infrastructure at AWS, AWS has the largest global infrastructure footprint. So we have 24 regions and 77 availability zones and 200 over points of presence, with more being announced always. And this footprint is constantly increasing at a significant rate. We have announced regions that are coming up also, 6 regions and 18 AZs coming across over here. If you want to know more about the infrastructure and you want to see more about the locations of CloudFront, you can just have a look at these links. I'll just paste it over here quickly. And you can have a look at this. If you go to the global infrastructure file page, you will go to a page where they'll actually show a nice map. Graphic intensive, but definitely useful to understand how the whole thing is set up. At a high level, like I mentioned a bit about the region part. So regions are comprised of multiple availability zones, and they're built for high availability and high scalability, and they have high fault tolerance in terms of how you want to set these things up. Applications and data are replicated in real time, and they are consistent in the different ECs. So all of this is managed for you, right? So as a customer, as a user of the cloud, you don't have to worry about this. You can be rest assured that the hardware is being handled for you on your behalf, because it's a managed service in your case. And we also use our own backbone provider for everything, for all this network data that's all going through. It basically gives you that peace of mind in terms of their data in being on the Amazon network versus outside. From a region perspective, like I mentioned, we have 24 regions, physical location in the world where we have multiple availability zones. And these are discrete data centers. And why I mentioned discrete is, even me being in AWS, I don't know the location of these data centers also. And it's been kept such a way because we want to ensure that the secrecy of these data centers are kept well, unless there is a certain reason for which it has to be disclosed through a certain legal process. And this allows us to ensure that, okay, we can focus more on, again, for the users, on applications. You can focus more on building your applications versus understanding where these things are. In this case, let's go here. Right. So fully isolated, they're fully isolated infrastructure, and there's also meaningful distance of separation. You have a certain distance between which they have to, they don't have to be in. So there's a minimum separation, and we have unique power infrastructure in terms of failover, in terms of data also. In terms of power, and multiple servers at scale, and data centers are all connected via redundant lines in this case. The network design is also built in this manner. So you have a fiber high-speed data transmission, each transit center also redundantly connected to each availability zone. So this kind of gives you an idea that, and I'll show you in a bit when we go into the AWS console, of how you can just quickly switch regions. Right, you can literally deploy an application to a user base closer to them, right, versus being over here. So I could be sitting here in Malaysia, and I could build an application and then deploy it in let's say in India, because I want a low latency for videos that are being streamed over there. Don't ask me what videos I would want to stream, but yeah, you get the idea. That's basically what you would want to do. So it's super easy for me to do that. I don't have to go in over there. I don't have to find a data center, then make a contract with them, wait for them to get the right hardware so that I can then start hosting all these applications together. So that at a high level is what hardware is all about, right? But what else are we talking about over here? So it's not just about just getting a data center and then you figuring out what to do with that, with all these servers running over there. You want more, right? You want more ways in which you can interact with all this infrastructure without you managing it. And at a high level, when you look at managing what AWS can manage, we always talk about security first, right? Because at AWS, we always believe security is job zero, no matter what. So in this case, here what we are looking at is AWS is managing and is responsible for the security of the cloud. So all this infrastructure that is being hosted over here, and all these networks that are being hosted over here, the hardware all the way up to the hypervisor, which you would get in a virtual machine, is all managed by AWS, and it's a responsibility of AWS for the customers. Now, where the customers start coming in terms of the shared responsibility model is what is in the cloud, right? So now it's as the analog is very simple. It's almost as if like I've given you the servers, I've given you everything, and I'm securing the hardware and all. But if you are someone who's set up an operating system on the hardware, and you have published your passwords on Twitter and Facebook, then of course that security of that server is in your hands, because you've basically publicly opened the PC to the world, right? You've basically opened the machine to the world. So that's basically where you would start looking at the responsibility of security from a user's aspect also. Now, even in this, there are different levels, right? So somebody actually mentioned DynamoDB over here as a a connection to what I mentioned briefly on NoSQL. So let's say, for example, you want to host a database, but you don't want to manage all this infrastructure for running a database, right? You don't want to manage the cluster, you don't want to manage backups, you want somebody else to do all this for you. So you would start looking at more managed services. DynamoDB, for example, is a fully managed NoSQL database service from AWS that allows you to have massive scale NoSQL data sitting in databases that are being handled by AWS on your behalf. So you would start moving up the stack, and then you start moving towards even things like, okay, managed containers, for example. For folks who don't know what is a container, it's basically a packaging of applications and runtimes together so that they can run on any host without worry of the operating system. And then you would go one level even above that, which is basically serverless. And serverless has been around for quite some time. I myself have been talking about serverless since 2017, and I'm in awe of the kind of services that are being released out every year in some form or the other for enabling more serverless application capabilities. So with serverless, what happens is that you just manage the code. You don't have to worry about any of the infrastructure. You just supply the code and then it runs. And the best part is you only pay as you go, right? So with serverless, you only pay for when your code is running. When it's not running, you don't pay for it. And we have different ways of actually doing serverless on AWS also. But maybe that's a topic for another day in that case. So this is at a high level now, and usually showing this to folks who are new to the cloud helps for them to understand a mental model of what they would want to expect from a cloud provider, right? Because you want to make sure that all of the undifferentiated heavy lifting is taken care of. You want to understand what the security model is like when you move to the cloud. Now let's talk a bit about how you would get started on the cloud, right? Directly now, the moment you want to get started, you wouldn't get started by saying, hey, I want to get a server first. And then once I get a server, I'm going to think of what I want to build. You actually would always start with a project, right? You would always have something you want to build. And in our case, just for today's conversation, it's usually what we would call an MVP. If you have maybe someone who's looking in the startup space, for example, or maybe in a company that's building new products, always you would come across this term, which is basically a minimum viable product, right? A product that has a certain set of core features that would appease a certain market. So that you can then get product market fit and then start building those products together. Now, when you have this idea first and you want to build this idea out, you want to make sure that this product is not only viable, it is also usable and it's lovable and also testable, right, with your user base, and it's possible in that case. Now, traditionally, how we have done application development, product development has always been this waterfall model. If maybe some of you would have learned that as part of your SDLC courses, if it's still being taught, I'm not sure. At least I had that at least in my time. And if you see on top, that's basically what a waterfall would look like. Someone says, okay, I want to build a car. And then they would make the massive plan of, okay, let's build a car. And everyone waits until the car is built and then tested. And if there's something wrong with the car, then nobody's going to buy it, right? And that's why you would see this massive amount of time for research and development taking place, because they want to make sure they're able to nail that product. But now things have changed. Now, I mean, we're in the era where people want to iterate faster. They want to test and experiment things faster. So you would, with an MVP, what you would want to do is you want to address a certain core feature first, right? Through which you can address a problem for a user, a smaller user base first, and then start expanding from there. And that's how this would look like, right? If you're let's say the analogy over here is for you're solving the problem of mobility for people to travel around. You would first give them something that allows them to travel around, and then you would start iterating over that and then make it better. And that's basically how this whole concept of being agile, of being iterative and being lean and always experimenting starts coming in. Now, if you would start look at whatever I've spoken till now about traditional hardware in terms of how you would procure hardware at a high level. I had spoken about how you would go to data centers and do all this. You would notice that's very time consuming. That's something that takes time. And you, as a person who wants to build new products, you don't want to spend time in doing all that. You want to go to a place where you're able to immediately build something, quickly test it out, host it somewhere, have users using it, and then be at a provider, be at a platform where you can scale up whenever you want. And whenever you don't have much users, you scale down. So it's always both sides. So it's not always about scaling up. You also want to be able to manage your costs better and only use resources which you really need to. And I mean, Reid Hoffman from LinkedIn actually has put it really well in terms of products. He's actually mentioned, if you aren't embarrassed by the first version of your product, you've shipped it too late, because should be shipping as much as possible, and you should be putting products in front of your users as much as possible, right? And another aspect in this whole product cycle is that you're busy trying to understand and solve a problem for a user while you have all this other things to manage in terms of infrastructure, right? You want people to manage you want your teams to manage the infrastructure also, and that's something you have to think about, because if you're going to actually build something, an application or a product, you also have to manage it. You have to run it in some form or the other. And this is basically how development iterations work right now, right? So you have this whole cycle where you're always continuously iteratively just going through, you're building, you're designing, you're building, deploying, and then measuring the output, right? Measuring something from user interaction on the product, and then deciding to build the next iteration and the next iteration. Usually you would have heard of for things like sprints, right? So you have complete sprints, and these sprints are usually complete, right? So after every sprint, you have something that's workable, and then they're uninterrupted. So when you're building stuff, you want to make sure that you're focusing on what you're building, and they're short, so that you can actually build the things faster and put it out there. So you want to have high impact items out there always, and then try to remove all the low impact stuff like undifferentiated heavy lifting or infrastructure away, and all the distraction away, so that you can have that focus area. And this is the sweet spot you're talking about, right? You should be able to build fast and also build things that are high impact for users and for your business. So super fast way to get started on AWS right now, if you ever want to do it, and we'll just quickly go into that demo, is that you would want to leverage a service that quickly gives you like a virtual machine, for example, or a compute instance that allows you to host your application immediately. So with that, I'll just quickly jump into a demo over here. And for folks who are new to the AWS management console, this is what it looks like. When you sign up for an account the first time, you have to give a credit card, and then after a verification, which takes usually less than a couple of minutes, up to 24 hours, depending on your issuing bank, you will get access to your management console, and you will be able to get started immediately. So unlike the old days, you can just use a credit card and then get started. Now, with this management console, this is where you would get access to all the services that are available. By default, you get access to every service that's there in your region. And when I meant regions and you can jump in and out, I wasn't joking. So you basically have regions at your fingertips over here. You could jump into any region over here, and you would be deploying applications in that region, and availability zones in that region, so that you can have better experience for your users nearer to those regions also. So in my case today, I'm just going to be at Ireland itself. Just keep it simple. But I guess with Lightsail, what's going to happen is it's going to jump in directly. So I'll just type in Lightsail quickly. And what I'm going to do is I'm just going to show you how I can set up a super simple blog, right? So I have a WordPress blog that I'm going to just set up. And what Lightsail does for me is it has actually abstracted a lot of things from the compute layer. So I can just create a machine and use a blueprint to set it up. So I'll just quickly do that. I'll just create an instance over here. And if you notice, okay, it still sees me because I'm in Singapore because of my IP address, but I can always change this. You can always change this to other regions over here that's available. And once you select a region you want, you can then select what operating system you want to run it in and what blueprint, or whether you want to run your own operating system. In my case, I just want to set up a blog, so I'll just keep it simple. So I'll just set up a WordPress blog. With this image, other advantages you get is when you set up a machine for the first time, you will notice that there are certain commands you would run, certain configurations you would want to set. And every time a machine is set up, you would have to go RDP or SSH into the machine and then set certain things up. You can actually automate a bit of that by adding a launch script. So the moment the server is set up, it would actually also run the script and configure the things based on the script you have put. So which is pretty cool. So maybe you want to download certain packages or update certain packages internally, you could run that through your launch script also. With Lightsail, you get an advantage of monthly plans. So you have like $5, $10 up to what, and you have things which I mentioned right now about processing. So you have a CPU, you have memory, and then you have storage, and also network bandwidth transfer out from the machine. So very generous bandwidth transfer limits over here in this case. So I'll just quickly set this up, and that's all I need to do. I just click a button, and then we'll have a WordPress image up and running. So give this a minute, it'll set up. But in the meantime, just being mindful of time, I just wanted to show you a bit of what we can do more, right, on AWS. So I'll skip the security part, but this at a high level is what you would get from a security perspective in terms of AWS, different services that allow you to secure your applications and secure your infrastructure better. You also get security and compliance controls also as part of this. So all of these are noted, and they're also listed on our website. So definitely something you would want to look at if you're, in the future working in companies where they're having regulatory compliance requirements also. From a data model perspective, like I mentioned a bit about databases briefly, we have services for each type of database in this case. And we have relational databases, which are basically having referential integrity between the data, and you normalize the data literally for that. If ever there's a talk on SQL and the history of databases, I would be interested to give a talk, because it's interesting to know how we actually landed up in relational databases in the first place, and how it has actually evolved over the years with our kind of requirements, right? When I was in uni, the only thing I knew was a relational database is the only way you can get application data in, and how much that has changed in the last 20 years. Definitely, it's very interesting to learn on that. In-memory is another one for caching, basically. So you have low latency. Then you have key value in terms of having like a dictionary or a hash map or JSON, basically data, and you can read and write keys faster. This is basically NoSQL, and you have different forms of NoSQL. So key value is one. So DynamoDB is that. Then we have a document store, which allows you to have key value and other things, but in the form of a document. And that's basically document DB, which has compatible APIs like MongoDB. Then we have a graph database and time series databases, and a ledger database if you're into blockchain, and ledger database for having transactions and then cross-checking references in terms of that. You also want to make sure that you're not building things from scratch always. You want to leverage off of what is already available, right? So you don't have to reinvent the wheel. You just have to attach it to a new wagon. So you get a wheel from somewhere and then build the wagon and then just put it across. And on this, quickly, I just wanted to show you a bit on machine learning, right? So the whole idea is that you can actually power up your applications. You can plug into machine learning APIs, which are already available, that allow you to leverage all of this across in this case. So I'll quickly show that. We have this up and running, but I just wanted to show you this so that at least you get an idea of what you can, the power of AI/ML APIs for your application. So recognition is a computer vision service which we provide in AWS that is powered by an API in front. So you just have an API and uses pre-trained models behind the scenes that allow you to immediately start using this out of the box. You can just go to this to the demo section and just have a look at this. But I'll quickly jump into one specific use case which you will usually see if you are someone who's using financial applications, or maybe like fintech applications, for example. There is always an onboarding process called eKYC, right? Electronic Know Your Customer, where you need to show your ID and then you need to take a selfie with your ID, and someone will eyeball it and then cross-check and say, okay, it's the same person in the ID. And that usually takes time, right? If it's a manual process, it'll take maybe at least 1 to 2 hours up to a day. And if there's an influx of eKYC signups, then it may take more days than that. What I'm going to show you is super simple. So the idea is that you can actually set up, upload two images to recognition under the face comparison feature. And you can just upload, let's say, once this opens up over here, let me just get an IC, which I have, right. And then I'll upload another person who is supposed to be him, and here you go. And yeah, so basically recognition is saying the persons are similar, the 99.9%, right? Don't ask me how Mr. Bean got an IC in Malaysia. I won't get into that, but definitely recognition is kind of showing that it's able to detect this image and then it's able to match it against this image. Also, if you want to do in eKYC, the other step is, okay, I want to extract the data out from the ID so that I can match it against something that's typed in a form, for example. So you could do very simple text, and you can extract text also from this. So I'll just quickly extract that text from here. And once you extract this, you can see, you can get the IC number, you can get the name, and all of this is just a response from an API. So you can actually see that you get a JSON object, which when you build an application, you can then use this data and then do certain things with that data, right? So you get all these bounding boxes, you get the coordinates for it, so you can show that. and you can already see that this is happening. So once you get the data, you can build whatever you want on top of that. And yeah, so that's the power of ML in this case. And this is just a very basic demo of what all we can do with machine learning. I could sit here for another hour just showing you what are the different things we can do. And maybe that's a future topic if people are interested in machine learning workshops, also of how to build certain things on AWS. That's something we can work with the club over here. I'll just quickly show this before we conclude. And so I have a WordPress website already set up, and this gives me a public IP address already. So the networking is already set up. And what I can do is I can just go into my blog over here, and I see, okay, there's a blog website already available. And I just want to log into the machine also. So what I'll do is I'll just connect using SSH. So it opens it in the browser. So I don't have to download any credentials directly. And all I'll do is I'll just check. Interesting. Okay, let me just try this again. I'll try connecting again once more from here. Sometimes my browser would not show. All right. Okay, fair enough. I think my browser is not cooperating today with me. But ideally, what happens is you're already SSH'd into the machine. And then what I could do is I could read the admin password that is already set up and then use that as part of my admin page for WordPress and then set it up directly over there. So that's basically in a nutshell how you get started with Lightsail. You have a server immediately with an image already running, and you have a working, functioning website already up and running. And you can do a lot of other things. So when you're setting up your own Lightsail instance, in this case, you could create another instance. If you're setting up, let's say, a Node.js application, you get that also out of the box. Over here, and so you'll have the runtime already set up. So 12.20 is already available. If you're setting up a PHP website, you can have a LAMP stack already set up. In our case with WordPress, it's set up the database inside the machine, but you can also have set up your own WordPress site where you have the apps running, WordPress instance running separately, and then the database running separately, because Lightsail allows you to also host databases separately. So pretty straightforward way to get started. And as you can see, there's more things to the cloud than just meets the eye. It's not just about hosting an application and then, like this on a blog. You can also look at leveraging EIML. You can look at leveraging other things like storage, for example, and also even event processing and data analytics. So a lot of things that get powered by the cloud. The idea is that sky's the limit in what you can build. And I'll just go to the last part. So you want to get started, and the way you would want to get started is that how you would want to get started is you just want to create and activate a new Amazon Web Service account. We have a link for that over there, which if I just click over here, I should get it. Somewhere in my browser, and then I'll share the link. There you go. And you can actually just access this directly. And so that's how you would get started with AWS. And then beyond that, you are also deploying and hosting a React.js application. If you want to do that, we have examples for that also over here. And for building a modern web application, managing budgets and credits, and also more hands-on tutorials if needed. I think I have the link somewhere. I'll just paste in the chat box quickly while we just conclude in this case. So thanks for your time today. The idea of knowing what the cloud is and what you are capable of doing, we just saw a glimpse of it, and there's much more that can be done. And definitely, we are always open to do more sessions, especially if it's hands-on sessions like workshops and all. And we would usually work with clubs who would arrange and work with you, the students, to understand, okay, what's the kind of content that's running right now? Because I've noticed that to understand what's the kind of requirements that are going on, sometimes you also want to leverage and connect with industry people, right? So we also know what's happening in the market out there, and then you want to learn, okay, what's best for you to put you in the best position when you actually get out and then start working in jobs. So definitely do sign up for the DevX Mentor. and I'll just quickly get the links for you. And in the meantime, if there are any questions, we can definitely start answering those right now.
Yep, definitely. Thank you so much. So if you guys have any questions, so you can either pop it into the chat and we will answer them, or you can even unmute yourself and ask us directly.
Yep.
So give a few minutes for that.
And we can take questions in general also, because I believe we have less people over here. So if you're asking in general about the cloud or even other things also, it's fine. I'll just in the meantime get my links somewhere. Also, I'll just quickly share. Yeah, where's those links? Here it is. Okay. So the chat box disappeared. Right, I'll just paste this over here. The last link is basically a collection which I use. I always collect a lot of interesting articles from AWS and from the community. And usually people ask me about sharing certain articles also around. So I have it in a collection called Tag Packer. The last link, if you click that, there's already some links there, but I always keep sharing more stuff over there. So it's useful if you're interested in learning in that case. And yeah. And I'm just curious from whoever's over here right now, how many of you are already building applications and deploying to the cloud? I mean, if you're not asking a question, I'm going to ask it, so it's fine.
Hi, my name is Saiki. I've got the solution architect associate certification, and like I've never used, I've never hosted application or whatsoever before.
I see. Okay, so you have a certification, but you haven't hosted anything on AWS.
Yeah, no.
I see. Okay, all right. So, all right. So that's one. I'm guessing about the rest. Then still quite new to all of this. Okay, awesome. So I think Monash is also one of the unis who is signed up for AWS Educate. So AWS Educate, if you go into AWS Educate and then sign up with your student ID, you should be able to get an account immediately, which gives you access to AWS, and then you can start building it. One thing I'll just mention over here is, like I mentioned earlier, right, about having an MVP. Even learning about the cloud, if you want to learn something about the cloud, start with the project. Just think very simple thing. Okay, I want to host a website on AWS. How do I get started, right? And then I've shared some of the links already. And then that's how you would start looking at, okay, you start exploring more. With AWS Educate, you get some credits already, and you also get access to some content. So that allows you to learn a bit more. The best way to learn is by doing. So theory is just one part of it. You also want to put it into practice. So definitely do that. And that's why I mentioned about workshops. I think having workshops is one of the best ways to do it. I'm sure the student club is already arranging this from before, but if there are certain topics you're looking for, do reach out to the student club and then tell them, so that then they can arrange for whoever to come in and then talk about it. Me, myself, I do also workshops outside anyway, community stuff. I'm kind of like in and around unis here and there. That's how I met Nitin also. There are, I mean, places where workshops would always run. So sometimes you may see there are announcements for public workshops, which are happening in other unis or maybe at a common place somewhere. We used to do this before MCO, but hopefully now with MCO slowly, I mean, things becoming a bit better. We hope in a couple of months, should slowly start having physical events. That's where then doing workshops even physically makes a lot of sense. But yeah, I mean, we'll see how that goes.
Yeah, definitely. If anyone has any suggestions for or requests for speakers or events that you want us to organize at DSC, put it in the feedback form. We'll definitely consider all your suggestions.
I have a question.
Yep.
Can you hear me? Is there any like internship opportunity at AWS Malaysia?
I'm sorry, there's some background sound at your end. Could you just speak a bit louder?
Oh, sorry. Sorry. Is there any internship opportunity at AWS Malaysia?
I think there was some openings recently. So you have to just keep checking the website. Let me just see quickly if there is still some openings for internships. And we usually do it at a certain time of the year. Oh, okay. I think there is one. Yeah, let me just paste it over here. So folks who are interested, you can apply for the Next Gen internship program. Next Gen internship program this is for. Okay, let me just paste this here so you can have a look at this one. Anyone who's interested, they can sign up. And let me see if there's another one. Okay, that's the only one, right? So we started having interns now in Malaysia. We didn't have that. So when I joined in 2019, we didn't have that. I think it's something that's just started in the past few months. So you can sign up over here and then have a look at it. Yeah. So if anyone's interested, you can just And internships is one way. I mean, but again, like I said, doing projects is the main thing. So if you ever get a chance to participate in hackathons, for example, do that. I mean, winning a prize is awesome, definitely, but do the hackathon even for learning something new, something that you haven't touched before, because usually a hackathon provides you an environment, a high pressure environment for you to build something, anything, and then you start like going through material faster than your usual uni study time. So just saying that as a way of forcing you to learn something new.
Also, I sent you a private message. Thank you.
Yep.
Awesome. I guess if no one else has anything else to say, we'll leave the floor open for another 30 more seconds. And if not, we can wrap up.
Yep.
No more question for me.
Thanks, Zaki. All right, Faz, I guess we can close the session, which was really awesome having you over. And if there is definitely any more events we're going to have with you, we'll let you know. Thank you for sharing the introduction of the cloud to the students. I'm pretty sure it must have been very insightful.
Yep. Thanks for having me. Appreciate it. And thanks everyone for joining in today.
All right. Thanks, everyone.
Thank you.
Bye-bye.
Thank you.
Have a great weekend.